All right, let's look at this think pair share. Again, this is one that you should try on your own and come back and maybe see how I did it if you need some help. A survey was conducted to determine the percentage of car owners who would pay to put nitrogen in their tires. Nitrogen supposedly leaks out at a slower rate than air, which keeps the tire pressure at the ideal level. How many randomly selected car owners should be surveyed? Assume that we want a 95% confidence that the sample percentage is within 3% of the true percentage of all car owners who would be willing to pay for nitrogen, um, and write an interpretation. Okay, so let's look at our given information here. We have a 95% confidence level, which means we're going to have a significance level of 0.05 and a significance level divided by 2 of 0.025. All right. Um, let's see what else. Let's see here. Assume that we want a 95% confidence and the sample percentage is within 3%. So that is our margin of error, 3%. Now we need to come up with, how many randomly selected corners should be surveyed. So we need a sample size. This is all we got. So you'll notice that this is an example where we do not know what the sample proportion of success is. We don't have any information on that. So this is where we use the other equation, this one with the 0.25. So what we need is the sample size is equal to z alpha 2 squared times 0.25 divided by the error squared. And of course, we have the error, but what we need is the z alpha 2. So let's do a quick sketch of that. And it's going to be two-tailed. This is our positive z critical score, our negative z critical score. Confidence level in the middle of 95%. Just double checking. Okay, alpha over 2, 0.025 in this tail. 0.025 in that tail. Okay, so we're going to have a z alpha 2 of, let's figure that out. All right, let me clear this out and need to go to inverse norm because we're converting an area into a number line value, a critical value. Okay, 1.960. I'll go ahead and save that into variable z. So let's store that in z. There we go. Numworks. Let me clear this out. Go home. Distributions. Okay, normal distribution from 0 to 1. But I want to change the area on the right to 0.025, 1.96. And I too will hit Shift X to the Y button to store it. Shift Alpha Z. There we go. Okay. So now, oops, sorry about that. Give myself a little bit more room. Sorry, screen jumped around a little. Okay. So we're going to have 1.96 approximately squared times 0.25 all over 0.03 squared. Okay, so we're going to have in the numerator z squared times 0.25 divided by 0.03 squared in the denominator, right? Z squared times 0.25. Yep, that looks right. All right, I go home, click, go to calculation. All right, in the numerator, I want z squared times 0.25 and divided by 3.03 squared. So I get 1,067 and some change. There we go. So 1,067.0, and it keeps going. So we want to round that up to 1,068. So that's a number of customers that we need to survey, or car owners that we need to survey, to see if they would truly be interested in filling their tires with nitrogen with a 95% confidence level. And you see this one, like we have no idea what people are going to think. So we can still conduct this calculation or do this calculation and just assume that the proportion of successes and failures is going to be 0.5 each, 50-50 chance. And that'll maximize this product here to 0.25 and give us the highest conservative sample size that we can use. Okay, so everything looks good. Let me know if you have any questions.